it is allowing us, this particular baseline model allowing us initially with k neighbors as I have put neighbors as 1, and I have implemented, I have fit my model, and as well as I predicted these kind of the things. Okay, I have predicted these aspects also. Now the point here is after verifying this accuracy and as well as other kind of the measures of the predictions, okay, I decided that maybe if I am giving knn value as some kind of the 5, I may get some kind of the better accuracy and better prediction. Now after some time still I can have a chance of giving that particular k value as 23, so that I can see in the yesterday's session only we have seen for k equal to 1 we got some kind of let me open that so that you can easily. At the moment I am talking about that knn. Yesterday we have decided, discussed these things, maybe earlier session. If you observe here, guys, see here, k equal to 1, we have seen some kind of the confusion matrix and all these things. If k equal to 5 something, and k equal to 23, some kind of the betterment. Now obviously if k equal to 1, whatever the model I have given, that model is nothing but the baseline model. Okay, that model is nothing but the baseline model. This baseline model is the initial model, which is the initial model. And this particular baseline model is not having any kind of I can say the hyperparameter tuning or nothing. Just like that, we have implemented that model and we are seeing the performance of that thing. That is what you call the baseline model. So that is the initial model, that is the base model. If you are not knowing this thing, if I am not explaining this kind of thing, you may feel, oh, that baseline means some high-end model. Okay, maybe some experts should do that kind of thing. No. Okay, this is how, friends, how you are how you need to prepare it, just to explore the things. However, in the meantime, I'll post some interview questions most frequently asked by us in the panel and all, as per my personal experience and all, and along with how market is currently. However, if I am doing the interviews, means definitely I should ask the current trends, and based on these things only we use it to ask the things. So just I'll post the things along with just you can answer those aspects, and if you are having any doubt, then definitely we can discuss those aspects also. Now coming to other important aspects, suppose if I am talking about the support vector machine, there we have used support vector classifier. And one more important thing, friends, two parameters we have seen there. Can someone name those two parameters in the support vector classifiers? One is the kernel, another is the C value. What do you mean by this kernel, friends? It is very important question.
Converts non-linear into linear.
Kernel trick, which is converts the non-linear into linear. Non-linear to linear. Now, if I'm saying non-linear, maybe that information is available in some different circle formats. Okay, maybe the data is not in the linear curve. So just we can apply some kind of the kernel so that it is segregating the things. Okay, maybe I'm having different aspects as a circle kind of the format. So I could able to segregate in a proper understandable way. So this is the kernel. Okay, the kernel trick is one of the best part of the support vector machine. Okay, so and one more thing, how many types of kernel tricks we're having? Linear, sigmoid, polynomial, and RBF, radial basis function. Okay, now one more point, we always observe here, the wrong interpretation is if I am using more complex model, I will get better outcome. Maybe if you are doing more hard work, you can be placed in a good company. But if you are sweating for complex model fitting, you may not get the best outcome, friend, because it all decided by your data set. It's not the strength of the model, friend. Again, I am saying, see, the strength of your machine learning model is completely by the data set curation only. If you are giving the best data set, if you are getting the best data set with complete pre-processing kind of thing, definitely you can make use of the advantage of the data set, and in a way you can get the better outcome. That is the main important thing. That means don't feel that always radial basis function or sigmoid gives the better performance when compared with the linear model. Can you defend this statement, friends, with some example? Long back we have seen also, we have seen some kind of things like, though the model is linear, unnecessarily if you are applying kernel trick and you are converting into the non-linear or something like that, or else if you are applying some heavy functions like RBF, sigmoid, will it give better performance, friends?
No.
Unnecessarily what we are doing, we are adding some kind of the superimposition on that particular data, and we are pulling that particular data unnecessarily into the non-linear fashion or something like that. That is we are making the things complications. Okay, so these are all not required, friends. As a data scientist, we feel that is a myth actually. That's what I said, no? So the people who are already enjoying the benefits and fruits of the machine learning and data science team, they don't want the other member to come into that area, because that is pretty easy. And simply if I'm talking about the artificial intelligence and all, you may feel that, okay, I'm going to write some heavy program in the robotics and rocket science. No, no, no. Okay, only the thing is you need to have the common sense, because artificial intelligence itself is striving for the common sense reasoning. Okay, that particular common sense reasoning generally helps us to get into the understanding of, okay, what exactly our requirement and how the machine is taking all these parameters into the consideration. That is the most important point we have to observe. And okay, so that means from the support vector machine, and we are having the support vector classifier. Maybe if I am working with the kernel trick, it doesn't mean that always I should go with the most complex kernel other than the linear. It is not possible to say that point, friends. Reason is it is all demand of the data set. If your data set is not having any non-linear kind of the relationship internally, you need not go beyond the linear model. Okay, it is perfectly all right with the linear kind of a thing. Now, one more thing we have discussed, grid search CV. In the last session of the support vector machine, we come across with this grid search CV. What is the meaning and what is the advantage of this thing, friends? Suresh, you can use your chat window. Grid search CV. In the earlier session also we have seen. So this particular grid search CV, friends, suppose I am having two parameters, parameter 1 with certain values, parameter 2 with certain values. So the first parameter is C. Assume that this is a regularization parameter we have seen. And second thing, friends, here, this P2 is nothing but my kernel trick. This is my kernel trick. Suresh has given some answer. It gives best. Very good. So now, if I'm talking about the C value, maybe my C value is 0.01 or 1 or 0.1. Like that, I can give three possible values, and I can give the linear or RBF kind of the kernel or sigmoid.
See, it works by itself and gives the best combination. Like it optimizes. We need not do anything. It only looks for the best possible solution. It calculates itself and gives us the best.
Yeah. See, the automatic suggestion in the available parameters, from the available parameters, I can say. But we should know about this thing, na? Because though the system is performing some kind of the automatic things for us, as a data scientist, as a machine learning engineer, we should know about what exactly this grid set CV. Even people are not aware of those points, friend. That's what I'm saying. Okay. Now, one point, learning of algorithm doesn't mean that. Okay, algorithm learning means what exactly? Suppose if I'm talking about the SVM, okay, I'm using the SVC. Some labels we have to point out. Okay, this is for the sake of the kernel trick kind of thing. And there are certain kind of the kernel trick aspects. Okay, and thereafter regularization is also there. And this particular SVM, we can make use of the grid search CV. The possibility is, why we are not using grid search CV for KNN, friends? Can someone help me? Why KNN is not using the grid search CV? Is there any number of parameters are there, friends, in KNN?
Yes, we have a number of parameters.
Number of parameters in the sense what? 5. Number of neighbors, 15, 23. But whereas, is it really difficult to decide ourselves by identification of the K? Not that much difficult, I can easily say.
Yeah.
But in this case, as my kernel trick is having 4 different things, my regularization is having n number of things, definitely I should bank on this grid set CV. That ability to decide when can I use the complex aspect, when can I suppress these kind of the uses. That is the advantage of data scientist, friends. If you are really having the understanding of the background thing, then you are done. Okay, that is a major impact, major aspect you have to cover. Now, coming to the introduction of this naive Bayes, just have a look on this, guys. What do you mean by the term naive? This is one point I want to ask. And of course, principle we know pretty well. So each and every learner
Equal importance, and also
will take equal importance, will give equal importance, and will compute the probability. Will compute the probability. This is the principle. Now now I will come to that point. Suppose I'm having 2 possibilities. Suppose a person is there, and if this particular person is can he fit into data engineering or data science? As an interviewer, so just I have interviewed him, because in data engineering we need to test his Hadoop, Hive, scope. Okay, and thereafter I can touch base on some kind of the ARN. This is a requirement. Whereas data science, my primary thing is Python. I have to check, and I should check the PySpark kind of thing. If any Scala orientation he is having, SQL skills, like that. Now we observe, guys. So the person applied for both the aspects. Assume that, and I am the interviewer, and I myself I need to decide. So how I need to decide is I should see, suppose 10 questions I have asked here in data engineering, and he has answered 7 questions. And here I have asked 10 questions. He could able to answer only 5 questions. Then tell me to which suit or to which technology he suits out of these two. Is a higher probability, no? Higher probability, no? Obviously he fits to the data engineering. Similarly, your naive Bayes, what it does is, so just it is we are having feature 1 and as well as the feature 2. Just the probability. Suppose I am having the 75% probability. Do I need to check the second one, friends, or shall I go with the first one? Probability, I am saying. Probability. Probability. What is the value of the probability? Yeah, 1.
0 to 1.
0 to 1. 75% of the chances are there for 1. Do I need to check the other chance, friends? No.
No.
Okay, it is only 25%, so that I can say this one I can do. But I am asking this question if I am having multiple features. Suppose as if I'm having F1, F2, F3 and F4, then how do you do this particular probabilistic analysis, friends? Because for two things I can say, how may see, no matter even n number of things are there, their total probability must be
1.
1. Now you see 25% of the chances, 50% of the chances, and 15% of the chances, 10% of the chances. That means our probability is distributed among these kind of the features. Obviously, you can rate this second one. Don't worry about that number of features. That is the analogy required, because many members study this naive bias is based on the conditional probability. They don't know what exactly the conditional probability. Okay, so conditional probability is something like, in a simplest terms, you need to explain, guys. Don't feel that I need to use technical jargons. If they are not understanding, they may feel that, oh, this guy is saying something which is not relevant to us. Okay, better we skip his candidature. Don't go by that side, guys. Maybe to impress the interviewer, you may use some the terms which are not there in the earth. Maybe they may be used in somewhere else in the country or somewhere else in the planet, and you are pulling all those things, all the blocks and all the things you have prepared. Definitely, we are not going to consider the things. You stick on to the question, whatever the member asked, and you try to connect with the scenarios, friends. One simple example I can give. Yeah, I have seen the same scenario in my project. Somewhere I got this particular issue, so that I have used this naive Bayes, because earlier we thought of using KNN, but KNN, all the numbers, okay, we have to scale those kind of things. But that situation demands the probability in the sense, again, we are having logistic and as well as the naive Bayes, but naive Bayes is taking all the considerations of each and every member. So we have voted for the naive Bayes. Such a simple explanation, guys, because you should give the flow like, yes, I have used this, I have faced the issue, and we got some kind of the optimization by using these kind of the considerations. That is the required things. Okay, you need not explain what is a sigmoid function, what exactly conditional probability definition. No one is interested on that, because even let me see. Okay, once we complete this naive, and then I will show you the basis of this naive bias. What do you mean by the word naive, by the way? Unknown or not completely explored. Those kind of the things are known as the naive. Okay. Those kind of the things are known as the naive. Now you observe this point. Suppose one algorithm is there, and that particular algorithm is assuming that another point, friends, another point in the discussion of the naive Bayes we have seen long back, but of course you can pull the point. One point is giving importance to
there is a condition that all are not they are all independent.
Excellent. There is no dependency. That's what I said. Naive Bayes is alternative name of Venkat. Now you observe. Can I say, guys, without seeing any data set, without knowing any data set, naive Bayes, what is he assuming? Yes, there is no dependency on the there is no dependency of the car. Can I say that, friends? Suppose one simple example I'm going to explain. There is some kind of the age of the member, and as well as his salary, and there is some marketing campaign which got the information whether that guy has purchased the product or not. No, without any, because what if I am giving this data to the naive Bayes, what it is basically taking. Okay, of course, giving importance to all the learners is definitely one important property, one useful property. But this holds good, friends, in all the cases. Can I say for every data set there is no dependency among the features? Is that holds good, friends, practically?
No, that practically it's not possible.
Not possible. That is what this algorithm itself we are saying as naive. That means it is not knowing anything, and without knowing anything, it is giving conclusion for us. And what is this Bayes? Bayes, you can connect the dots. Something like Bayes theorem is there, na?
Yeah.
Bayes theorem. What it for? Conditional probability. Based on this particular conditional probability, one can easily refer what exactly the kind of aspect. Okay, so this is how you can refer the notation of Bayes theorem. Have you remembered the what exactly Bayes theorem is giving, friends, for us? What do you mean by
P of A given B, something like that.
yeah, P of A given B? Just you can refer. What we are doing is just I am making use of that particular thing for you guys. See here. So likelihood, posterior probability, prior probability, and all these things. So probability of C given X equal to reverse probability of X given C into probability of C by probability of X. Like that, we are going to perform some kind of the activity for all the things, so that you can able to refer the kind of specification. Okay, so and we can apply the things. And now the advantage here is simple. The algorithm is simple, and we are giving importance for all the considering of the weak learners and all. And one more important thing there we have seen is which is good for binary and as well as the multi classification. That's what. Though we are having many features, but still the probability drives those kind of the things. One more important point we have said, friends. Naive Bayes is very good for which is best for text classification, friends, actually. Because suppose if I'm working with some kind of sentiment analysis, in that particular case this test is giving yes, no, maybe, or else good, very good, super, excellent, like that we're having. So the underlying meaning should be observed in the probabilistic analysis, something like that conditional probability. Where if you are getting more probability related to the negative conditions, then we can say that, okay, this product is not liked by the members. Whereas if you are getting the positive conditions, so that you can have a look of that particular positive conditions. Okay. Now, just to give the basis, friends, let me give this naive Bayes kind of thing for you, so that you can have a look how we can see and how this is distinct with other kind of the templates. Okay, so naive Bayes, as usual, our first step is importing the libraries. And here what I am doing is, friends, I am getting the information about the customer purchases, who has purchased the appropriate content. So just I am running this, and we are making use of purchases. And let me insert, okay, one cell and data set. See here what exactly it is: age, estimated salary, whether he has purchased the thing or not. So that means corresponding to age, we are having some kind of the salaries. Now what is this for? X value and Y value. Suresh asked one doubt actually in the earlier session. We have been using different kinds of the thing. What is the use of ILOC, friends? Important interview question. LOC and ILOC.
It gives a default or internal location index value.
Okay. And
LOC is what the user defined.
okay. Okay. So that means if you are referencing the standpoint of the notation, like, suppose at the moment you are taking these kind of the conventions here, LOC, which is simply giving the specification of user defined or predefined. User defined. ILOC means internal, which is Python way. So Python way of doing the things. So here what we are doing is just we are taking the features in such a way that I am having some data set with me, and this particular data set I am picking up ILOC. That means all the rows. This is the all the rows, and up to what extent I am taking, friends? -1. In case of LOC, if I am using -1, can I include or exclude? Include. Okay, but ILOC I am using, this is definitely exclude. If I am excluding -1, that means
only features.
Only features before that, because this purchased is nothing but, friends, what is this purchased actually?
Label.
This purchased is the label, which is the -1, and this age and estimated salary are our requirements. Okay, so coming down, and now you see here what I am having here, just I am making use of the convention, like this particular aspect. What it is saying is just I am using the all the rows, and I am not mentioning any colon, so -1 dot values. Okay, so that -1 directly I am specifying, friends. I am not subscripting the thing, so that I am explicitly mentioning that last label purchased is also used, or I want to place that particular purchased in my while. There is no much differentiation. Now, how I can distinguish, friends? What is the relevancy of that particular aspect? How I can distinguish? Here, if you observe these kind of things, train test split, same kind of the aspects. Okay, so like whatever the considerations I'm having, just I'm making use of the convention. Okay, here sklearn model selection, import test train test split, x train, x test, y train, y test, same as it is. And now this time, what is the test size we have taken? 0.25. Now just I am printing X train and Y train, which I not required actually. So just to understand the appropriate outcome, X test value also I have printed. Now see, why feature scaling is required, friend, for naive bias? Why feature scaling?
No, because it calculates the probability, based on.
Excellent. How you got the point, Venkat? Because I have not mentioned any probability. Because scaling is other way. Just we are getting the things from 0 to 1 or something like that. How you could able to connect the probability? Because naive bias is revolving in two things. One is embedding all the features. That important point. Second thing is probability. Maybe that is a conditional probability or whatever. Okay, so the convention here is, friends, whatever the naive bias kind of thing we are doing, it is not for the sake of maintaining the standardization for all the data, but we need to compute the probabilistic values, conditional probability, so that it is always better to convert those things into the proper scale. That's what we have done. What do you mean by this is standard scalar? This is the third time we are seeing. In the pre-processing, we are having the standard scalar. Why we need fit and transform? Fit and transform. Fit is logically converting the data. Transform means whatever the data item we are having, just we are going to transform. Now you see here for the X train, we used the both fit and transform, but for the X test, we have used only the transformation. Why, friends? Is there any background behind that? You can easily see what exactly X test here. If I'm talking about the X test, what it is giving? 25% of the data, 25% of the data. So just I'm not using that particular X test in my training actually. If you see, only I'm using my X train values in the training, and my X test values I'm going to give as a predictions actually. so that I need not convert any kind of the probabilistic values and all, so that just I am transforming. I am not embedding the fit and transform kind of thing. That is one more important point we have to observe.
One question: what does it transform when you're not using the fit here?
X test values directly. Now you can again I have printed this X train, and so just it is directly taking the X test value and it is going to transform that. This one, see. Okay, so you need to observe, or else I'll do one thing. So just let me give you this thing, fit and transform. Yeah, see what is the documentation, though you are not getting. Okay, fits transformer to X and Y with optional parameter, fit parameter, and returns a transformed version of the X. But whereas if you are referencing this transformation, what it is doing, perform only standardization. It is only performing the standardization by centering and scaling. So the differentiation here is in the X train, as I am making use of that particular X train as a parameter in the model also, to fit the corresponding model also I am using that, so that I have to give the fit and transform. Same thing we have used in earlier example also, if you remember. Where do we use it, friend? This thing we have used somewhere, simple or multiple linear regression. We have taken the standard scalar, maybe in the use case itself before starting of the regression and all. Just we have used these kind of the thing. We have only transformed the things with the test data, and we have fit and transform. Fit and transform we have used in the training data. Okay, both the things we have used. Now coming to the aspect, friends, here, once we got the appropriate information of transforming the data, now what is the process? We have got everything with us. Now is fitting the model. Now just you need to go back, friends. What do you mean by this Gaussian?
Gaussian is the normal, it follows the normal distribution.
Excellent. Normal distribution of the probability. So generally we are using the conditional probability, so that what we are doing, we are making use of, see, from sklearn.naive Bayes, import Gaussian naive Bayes, and as usual, just I am taking the Gaussian naive Bayes reference as a classifier dot fit X train and as well as the Y train, and then we are predicting the model. Okay, now one more point I added, friend, just to come across this particular thing, what we have observed from this particular thing. Can you give the observation of these, friends? What do you mean by this? So I have fit the model here. What I have done is, with my model, whatever I'm having, because my entire model is in the classifier now. Can someone elaborate this particular thing, friends? What is the advantage of this thing? Not advantage. Can you give what is this value? This is the age. This is the salary. Okay, that means 30 age, 87,000 salary, whether he purchased or not. He has not purchased. Here just we have tested our result, friends. See, maybe 30 may not be there in our data set. Age 30, let me see that. That is there. Okay, no problem. 30 and 87,000 are there. Whether he has purchased or not, friends? He has not purchased. See the outcome. Hope you got the point, friends. He has not purchased the things. Okay, so that means I'm having some value related to that particular 30. Though he is having age of 30 and as well as 87,000 salary, but he has not purchased. Just as a kind of pre-check, just I have done that, because in the earlier examples we have not seen this kind of implementation, so that I thought of giving this thing to you. Generally, I thought of you maybe having some kind of application. Okay, once my model is there, if I want to check if I'm giving 30 and I want to get some value, then how do I get the outcome, whether it is suitable to existing things or not. Now you see here, friends, how I am making use of this particular test result is, I am predicting my model. Up to this, you know that But now what I'm doing is I have done some kind of the analysis here, friends. If you could comment on this, I would be very happy just to spend some time to understand a little bit different. I'm going in the naive bias because we have come across with 4 algorithms earlier. Now this is the 5th algorithm we are talking about. So that I want to add some more points in the current specification. That's what I'm using this thing. Okay, up to this it is okay perfectly. But what do you mean by the next convention? Here I have used my Y prediction. This is my Y testing. What do you mean by Y prediction, guys? Our
What
method.
the
Our
model,
method. Y test means
the actual.
actual. Now you see. Now anything coming into your mind? These are all equal. So our model could able to perform this. We got some negative result.
So we are just trying to compare both what we got it and
That's
what
that's
the
what.
actual thing. We brought with the concatenate, we are bringing it together side by
Together.
side.
That is what. Exactly, friends. That's nothing else I have done. Because see, here itself you can easily say how many values are there and how many are true and how many are false. So here we got some failure. Okay, this thing got failed. Whereas yeah, this also failed. Okay, 0 1, because we have predicted, our method has predicted 0, but that guy has purchased. But our method got predicted as 0, but that guy has purchased. So like that, there is a because we have to do something else now. Like apart from observing the things, you can perform some kind of the activities by comparing the things. Okay, so here two considerations we have taken. First consideration is by simply giving one value, one a sample, I can say one particular sample, and I want to check whether that guy has got the correct value or not. That is one thing. And thereafter, what we have done, let us pick. Okay, let us concatenate these two things. Like, you know, I'm having my predictions and as well as I'm having my test values together. If I could able to do, obviously I can see the relativity between those two. Now, what is this for? Confusion matrix. This is a pretty straightforward. Now we are using from many at times. So at the moment I am referencing this particular confusion matrix and accuracy score. Obviously, the metrics, which are all the what is the accuracy score, friends? We know the confusion matrix, which is giving true positive, true negative kind of thing. And one more advantage we got is, along with the confusion matrix, what we are seeing, friends,
Accuracy.
classification report. Actually, we have taken the classification report, but for that particular classification report, what we need, friends, for the classification report, what is required? Again, we need to have the accuracy, precision, those definitions we should know now, because it is giving F1 score, it is giving some support. These definitions, if you are knowing, then we are okay. But whereas without knowing the definitions directly, I cannot use these classification reports. So the best score is accuracy score. Directly what I am doing is accuracy score of Y test and Y predicted is giving 90% of the accuracy. So see how much simple this is, but you need to observe one point. Unlike in case of other things, we have done a little addition of the in a different way we have done in the naive bias, that is giving the kind of value, okay, whatever the value we are having related to this salary, age and salary, and then what we have done, we have put together our Y predicted value and as well as the Y test values. So obviously I can easily grasp, okay, wherever I got some kind of the negation. And these things are pretty common. Confusion matrix and making use of the accuracy score. All these things are as usual. Okay. So hope you got the point, guys, related to the naive Bayes.
One question. See,
Please.
what is that? What is that problem statement in this naive bias?
Problem statement. Okay, let me give that. Problem statement is suppose a manager who is having some team of data scientists, and here the release of new car, maybe some Mercedes or something like that, and they're having already some kind of the data with them. So age of the person and as well as the estimated salary, and whether they have purchased their product or not, this data they are having. Now what they are doing is that manager thought of, okay, our batch is there, data scientist batch is there, so that I could give this particular data to them, so they can come up with a nice strategy of maybe naive bias or SVM or whichever. So at the moment they are giving they have given this particular data. After getting this data, they need to apply some kind of the algorithm, and they should come up with whether these guys are going to purchase the data or not. I mean SUV or Mercedes or whichever. Now after fitting our model, you can check with any kind of the data, maybe the person who is having some 35 years and with the corresponding salary, because already our classifier got some information. Let me do that. Let us see. Suppose if I'm giving some other information which is not there in the list or something like that. Okay, this time what I'm doing, I'm taking some kind of the value as 45, and this thing I'm giving. That means what it is saying, yes sir, is going to purchase. So either I can check case by case, or else I can give my model to the appropriate data set like this. And if I am able to send that particular data set, so that I can come up with the accuracy and as well as the prediction.
So it works on the age and salary combination.
Yeah.
Whether there is a chance of that person buying.
Definitely. But of course, one thing, though, as a human, we can say there is a relation between age and salary. But what exactly naive bias is doing? Naive bias is splitting, and it is assuming that what it is assuming?
All are
There is
equally
no-
important.
All are equally important, and there is
not
no relation.
dependent.
There is no dependency. Now I am giving one task to you guys. Within this thing only I am typing. Just you can simply, okay, apply the SVC on the same data set and discuss your observations. Okay, discuss your observations, because okay, now you are having SVC in your hand. Only the thing is you need to change at a particular a location. Okay, maybe instead of naive bias, you need to take the what you should take, friends? SVC. Okay, support vector classifier. Just you need to mention sklearn dot classifier import SVC. SVC equal to whatever the classifier equal to SVC. Classifier dot fit of this thing. Just you need to change this algorithm, and thereafter you come up with this confusion matrix, and as well as the that accuracy score, and as well as the report is there na? That confusion matrix, and as well as some kind of the report, classification report. Both the things you can apply, and you can compare these two. Okay, just you can take this as a case study. Okay, I have applied on the naive bias. I have applied a naive bias on top of the data set whatever I'm having. Now I want to apply the same kind of the condition or same kind of the data set with the SVC. So you can observe the distinction, friends, because the reason is we can easily say that this age and as well as the salary definitely dependent. So let us see if you apply, because I have not given SVC to you in the earlier thing, because simple this SVM we have taken as another case study, that is not definitely loading the cancer data set. This is a different case study. Now what I am doing is you can apply this support vector classifier related to this data set, whatever the SUV purchase or Mercedes-Benz purchase. Okay, because assume that there is a car company and that manager has given the data set to us, and we need to test okay some different categories of the algorithms, and you have to come up with some kind of observation, okay, whether which is better or which is not. Okay, so that is what how you can refer the uses of SVC and as well as the naive. Hope you got the insight, friends. Actually, okay, let me take this out. So what is the key takeaway of this session? Can someone help me?
It's in naive bias.
1 minute, friends. Okay.
You've seen what this basic line model.
Baseline model initially. And thereafter we
Talked about
discussed
the grid search and
SVC
naive bias.
grid search. And thereafter we
Naive
introduced
bias.
what exactly naive means and which are all the aspects related to naive bias. Two important things now. One is the Bayes theorem. Second thing, friends, independency among the features. Independence among the features. And next important thing is there we have implemented NB on top of this customer purchases data with the age and as well as the salary, whether that guy purchased or not. Okay, so that's it. Okay, here we have seen some more metric. This particular metric, friends, what is that? Accuracy score. Directly, rather than complicating the things, if I want to perform some kind of direct taking of this particular score, then I can go with the accuracy score. Okay, so that is all, guys. Okay, that's all for today's session. And in the next session, just you come up with just I'm going to introduce you the logistic regression. That is one thing. And you just to prepare the assumptions in logistic regression and sigmoid function, because most commonly used algorithm in case of the classification, though it is regression name, but we have seen that it is definitely related to the classification because it is giving yes or no kind of the representation. Okay, anything else?
Assumptions in the sense, the assumptions what we have done for regression.
Regression assumptions.
Linear,
What is, which are all the assumptions?
yeah, we have talked about four. One is fitting linear model to a non-linear additive. The second
additive.
one is
Additive.
the error
homoscedasticity,
and
heteroscedasticity,
autocorrelation. Errors, the errors
yes.
are getting autocorrelated.
Those points just to prepare, because those points are really helping us to understand the internal aspects of the logistic regression. Okay, so do well, friends. Just to go through the at least just I'm strongly recommend you guys just to open the OneNote at least. So and start from the end. Actually, here daily we are talking about these key takeaways and all, so that you can have a look on these kind of the aspects. So and whenever you are not getting the pulse of these either of these things, little bit go ahead and you come across, and if still you are in the doubt, just you go through the recording and note down all the points or whatever the doubts we're having. Then obviously in the next session we are going to clarify those things. Okay, right, that's all. Take care, guys. Suresh, thank you very much.